mechanical property of fluid. So first, what do you mean by fluid? So you will say the matter which having tendency to flow are termed as fluid. Matter having tendency to flow. So it will be gas and liquid both. First thing is density. So density is mass of a body divided by its volume. For water, density is 1000 kg per meter cube or 1 gram per centimeter cube. Is it clear?
Yes.
And next term is about density for any two different substance. Relative density. So it is just a ratio of density of any substance to the density of water at 4 degrees Celsius. So it will be maximum at 4 degrees Celsius. Density of any substance divided by density of water. So it will be termed as relative density. So it will be just a ratio or a unitless quantity, which may be equals to specific gravity. Wahid, is it clear till this part? Okay. Shoaib, any doubt? We just write it down.
Done.
Okay. So we mainly divide this particular chapter into two parts. First study. First is hydrostatics, means fluid at rest. Second is hydrodynamics, fluid in motion. In hydrostatic, we'll learn about pressure, Pascal's law, pressure due to column of liquid, application of Pascal's law, about hydraulic lift, and so on. Next is Archimedes' principle. Next is surface tension. In hydrodynamics, that is flow, first is viscosity or Newton's law of viscosity. Next is flow of liquid, Stokes' law, terminal velocity, Bernoulli's theorem, equation of continuity, torusity law, and so many things. Okay, so let's start with pressure. Suppose you have a surface like this, and force is applied on this particular surface at different inclination. Let's say a force is along this direction, another is along this direction, another is along this direction, and so on. So if force is applied on a surface perpendicular to it, then that force is termed as thrust. So thrust is perpendicular force acting on surface. Is it clear?
Yes.
So pressure is due to that perpendicular force applied over that particular surface. So you'll say pressure is basically due to thrust applied. So pressure is the thrust applied on a surface per unit area. So P equals to F perpendicular divided by area of cross section. Force measured in Newton, area in meter square. So SI unit is Pascal or Newton per meter square. Since there is no proper direction of these two terms, so it will be termed as scalar quantity. Is it clear?
Yes, sir.
Wahid, any doubt? Okay, just write it down. Shoaib, any doubt?
Done, sir.
Okay. Shoaib, you have written? A force of 10 Newton is applied on a pin to inject on a surface. If area of tip is 0.5 mm square, find pressure. We have force and area of cross section. Just use the above formula and try to find. Force is 10 Newton. Area of cross section is 0.5 mm square. So convert it in terms of meter square. So it will be 10 to the power minus 6 meter square. And just put all the values in the above formula. You will get pressure is equals to force by area. Force is 10, area is 0.5 into 10 to the power minus 6. So it will be 100. This 5 into 2. So it will be 2 into 10 to the power plus 1 and plus 6. It will be 7 Pascal. Is it clear?
Yes, sir.
Abdul Wahid? Okay. You all have written till this?
Yes, sir.
Shoaib, any doubt? Next is pressure exerted due to column of liquid. Pressure exerted due to column of liquid. which is also called gauge pressure. Suppose there is a container in which liquid is filled up to this like this. Just assume a cross-sectional part or a segment like this. Having height h and area of cross section A. Consider a cylindrical segment of area A, height h in a liquid having density rho. Mona, any doubt?
No, sir.
Okay. For pressure, we need two different terms. First is force and second is area of cross section. So first is force exerted. So it will be due to the mass for this considered segment of liquid. So mass times gravity. Mass is density into volume. So rho into volume into gravity. Volume is area of cross section into height into gravity. So this will be total amount of force exerted by this hypothetical column of liquid in this part. So pressure equals to force exerted by area of cross section. Force is rho A H into G. Area of cross section is A. So this A and this A will cancel out. So you'll get rho G H only. Now this pressure is due to column of liquid. So it will be termed as gauge pressure. So we may write it as pressure gauge equals to rho GH. Which is depending upon three factors. First is density of liquid, second is gravity, and third is height or vertical column. So this is density of liquid, G is gravity, and H is vertical column of liquid. So you'll say this pressure is independent of amount of liquid first, and it will be independent of direction of acting. Is it clear?
Yes, sir.
So it will be independent of amount of liquid and also independent of direction. First, write it down till this part.
Done, sir.
Shahab, you have written? Okay. Suppose you have a container like this, in which liquid is filled up to this point. At same horizontal level, I've taken a cross-sectional area along this direction, for which pressure is P1, another at this point, for which pressure is P2, another is this, pressure is P3, and another is this, pressure is P4. So from this point, at same horizontal level or at same depth h, pressure will be same in all part. So you'll say it will be independent of direction. So P1, P2, P3, and P4 will be equal. I will prove this particular statement using Pascal's law, okay? The next thing is, if there is connecting tube having different cross-sectional segment, let's say first is like this, the other is like this, next is like this, other may have shape like this, and so on. And all are connected like this. So if you start filling liquid from any one part, you will observe the level of liquid in all segment will be at same height. It means pressure exerted by these column of liquid At this point, let's say P1. At this point, let's say P2, P3, P4, and P5. These all should be equal. So it will be independent of amount of liquid. It just depends upon vertical column placed over it. Is it clear?
Yes.
Wahid, is it clear?
Done, sir.
Shwab, you have written? Wahid? Okay. Next is atmospheric pressure. You must have learned about that in your class 7th, 8th. The pressure exerted by air or atmosphere on all objects living on the surface of Earth is called atmospheric pressure. So it will be the pressure exerted by air on object on the surface of Earth. So we have to find its numerical value. Suppose there is a bath of mercury up to this level. And an evacuated capillary tube is placed inverted in this part, like this. Let's say a point at this A, another at this, let's say B. So Mamuna, tell me, is the pressure at point A equals to pressure at point B?
No.
Why so?
Because I think in the center of the fluid, the force is at normal. I mean the pressure.
Now suppose if this particular tube is shifted slightly to this point, position A, so how will pressure point A and B will be related? Are they become equal? You'll say, since at point A, there is pressure due to air like this. But in this point B, which is inside this particular capillary tube, which is evacuated, means there is no air inside it. So there will be no anything or any matter which is applying or generating pressure at point B. So pressure at this particular point B will be 0. Is it clear?
Yes.
So due to this particular pressure difference, since at point A, pressure is due to atmosphere and there is no pressure at point B. So matter or this particular liquid will move from higher pressure to lower pressure. Is it clear?
Yes.
Due to which level of liquid start rising in this tube, let's say up to this point, whose height or column is measured experimentally as 76 centimeter. Now you can say pressure at point A is due to air and pressure at point B is due to the liquid column raised in this particular part up to 76 centimeter. And there is no further flow from this pan to this particular column, which means pressure at point A and pressure at point B are equal. Is it clear?
Yes.
Wahid, is it clear? So in equilibrium, pressure at point A is equals to pressure at point B. Pressure at point B is due to the liquid column raised in that particular column. So it will be rho GH. Since this is mercury, whose density is 13.6 into 10 to the power 3, gravity is 9.8, and column of liquid raised is 76 centimeter. So divided by 100. So on simplifying it, you will get 1.013 into 10 to the power 5 Pascal. And this pressure is due to the air above this particular point A, which is also called atmospheric pressure. So it will be just 1 atm. So in terms of mercury column, we may learn it as 76 centimeter of Hg, means the column of 76 centimeter high of mercury will generate as much amount of pressure as much or equals to 1 atm. Is it clear, Mamuna?
Yes, sir.
Okay, just write it down.
Answer.
There is some other unit of this particular term. One is 1 bar. Next is next is so it will be equals to you all have written till this?
Yes.
Wahid? Okay. Now, if you combine these two terms, that is atmospheric pressure and gauge pressure, it will be termed as net pressure or absolute pressure. So absolute pressure exerted at any point will be equals to sum of atmospheric pressure and gauge pressure. Let me give you a question related to this. Find gauge pressure and absolute pressure at depth of 10 meters below the surface of ocean. Take the value of gravity to be 10. Try to find. Put the formula. Put all the values.
Sir, rho we should take 10 to the power of 3, right? Because of
Yeah.
density of liquid.
as gauge pressure equals to rho GH. Rho is density of water, that is 1000. G is gravity, 10. And depth of liquid is 10. So it will be 10 to the power 5 Pascal. For absolute pressure, or you may write it as P net equals to atmospheric pressure plus gauge pressure. Atmospheric pressure is 1.013 into 10 to the power 5 plus gauge pressure is 1 into 10 to the power 5. So if you take out common as 10 to the power 5, you will left with 1.013 plus 1. So it will be 2.013, or you may write it as 2.013 into 10 to the power 5 Pascal. Is it clear, Mamuna?
Yes.
Wahid, is it clear? Shoaib, any doubt? Abdul Wahid? Okay. Let me give another question. A submarine is at depth of 20 meter, whose inside is maintained atmospheric pressure, find force on its window having area 20 centimeters square. Let me give you a hint how to simplify it. Suppose there is a window like this of submarine, which is 20 meter below the surface of water, whose inside is maintained by atmospheric pressure. So there will be pressure from inside, P naught, and there will be pressure from outside, that is absolute pressure. As I have defined earlier, pressure at any point will be independent of direction. You may take direction, any direction. It will be in upward direction, left direction, right direction, or bottom direction. So in this part, we have to apply that particular pressure on its window. So it must be along horizontal direction. It is at depth of 20 meter from the surface of water. So just calculate P absolute and subtract it from atmospheric pressure. So you'll get net pressure. So it will be P absolute minus P naught. So it must be equals to just got rho GH. Now you have given area of cross section. Just multiply it by pressure. You will get force exerted, as pressure is equals to force by area. So force is equals to pressure into area. Is it clear, Mamuna?
Yes.
Okay. Just put all the values and simplify it. Go ahead. You have calculated. For gauge pressure, rho is density of liquid. So it will be 10 to the power 3. G is gravity, which is 10. H is column of liquid, which is 20. So this will be your net pressure acting on window pan into area of cross section is 20 centimeters square. So just convert it in terms of meters square by multiplying it by 10 to the power minus 4. Then simplify it. 2 into 2, 4 into 10 to the power 1, 2, 3, and 3, 6 minus 4. So it will be just 2 Newton. Is it clear? Namuna, we have to convert first area from centimeter square into meter square. Okay?
Okay, sir.
Abdul Wahid, is it clear? You have written? Next is Pascal's law. Suppose you have an enclosed vessel like this, in which incompressible and non-viscous liquid is filled, which is connected by or joined by different piston. Let's say there is a piston at this point, another at this point, at this point, or at this point. So if a pressure is applied at any one end, let's say at this point, P1 is applied to this particular enclosed non-viscous liquid. So the pressure exerted at this point, let's say P2, pressure exerted at this point, P3, and at this point, P4. These all pressure would be equal. Is it clear?
Yes.
So you will say for an incompressible liquid enclosed in a vessel, if pressure is exerted at any one end, it get transmitted in all direction without getting diminished. It means pressure at first, second, third, fourth should be equal. This is the first consequence of this Pascal's law. The next consequence is pressure at same horizontal level will be always equal. I will prove it, and which you have to prove in your examination. First, write it down.
Done.
Wahid, is it clear? You have written? Okay. This first form of Pascal's law. In next part, it will say at same horizontal level, pressure will be same in all direction. Let me prove it. Suppose there is a flask or a container in which liquid is filled up to this point. Like this. Now in this part, I'm taking a cross-sectional segment, strip, like this. Whose area is A, whose vertical component will be along this direction, and horizontal component along this direction, like this. So there will be theta from this point to this point, this term. Now, suppose a force is applied on this cross-sectional area, F. Is it clear?
Yes.
So we may break this particular force according to this particular theta into their component. Let's say this is inclined surface, theta, and a force is applied along this direction. So if you draw a vertical line from this theta will be equals to this term. So this will be F. So depending upon this theta, this F will have two different components. So one will be along this direction and the other will be along this direction. So this will be termed as F times cos theta, and this will be termed as F times sin theta. Is it clear?
Yes.
Similarly, we may break the area or component of area into two parts. Let's say this is your area, which is inclined at some angle theta. So for this area A, this base component will be A times cos theta, and this perpendicular component will be A times sin theta. Wahid, is it clear how I have just resolved the different component? Let this F is applied over this particular segment having area A, for which I have just resolved according to this theta, two different components. One would be along horizontal line and the other is along vertical line. So due to this force F, which is acting along this direction, so this theta and this theta will be equal. So for this theta, component of force along this particular space will be F cos theta, and along this direction, it will be F sin theta using resolution of vector concept. Similarly, A's area of cross section of this strip from this point to this point, which is inclined at some angle theta with this part. So this will be termed as base component. So it will be A times cos theta, and this will be perpendicular component A times sin theta. Is it clear now?
Yes, sir.
Now suppose this is surface first, this is surface second, and this is surface third. For first surface, Pressure is equals to force divided by area of cross section. So force is F, area of cross section is A. Let's say this is equation first. Similarly, for surface 2, that is this perpendicular part, force on that component is F sine theta, and area of cross section for that part is A times sine theta. Sine theta and sine theta will cancel out, so it will be F by A, equation 2. Similarly, for third part, P3 is equals to force by area. Third part is this base component for which force is F cos theta and area of cross section is A cos theta. Cos theta and cos theta will cancel out, so you'll get F by A only. Third equation. Just compare all of these three equations. You'll observe pressure P1, P2, P3 will be equal. It means at same horizontal level, pressure will be independent of direction. So in all direction, at same horizontal level, pressure will be equal. Is it clear?
Yes.
Wahid, is it clear? Okay, good.
Done.
Wahid, you have written? Okay. Okay. Now there is some application of this Pascal's law. Hydraulic lift. Suppose this compartment like this, or connected tube, which is filled by any thick liquid, which should be non-viscous and incompressible. So there's a fluid in this part. Up to this point, which is non-viscous and incompressible. There is a piston at this point having area A1. Another piston at this point having area A2. Now, if a force is applied at this end, first end, let's say F1, so it will generate pressure on this particular liquid. So P1 will be equals to force divided by area of cross section. Now, according to Pascal's law, if a pressure is applied at any one end in a incompressible and enclosed vessel for non-viscous liquid, this pressure will equally transmitted in all direction without getting diminished. So there will be force exerted F2 at this point. Similarly, pressure at point 2 will be F2 by A2. So according to Pascal's law, pressure at first point should be equals to pressure at second point. So on putting all the values, you will get F by A equals to F by A. Mamuna, is it clear?
Yes, sir.
So we can generate a large amount of force by just pushing with small force on this small piston. So the greater the ratio of area of these two pistons, it will generate larger amount of force and which will be capable of uplifting different heavy objects. Abdul Wahid, is it clear? Okay, just write it down.
Done.
Wahid, you have written? Okay. The ratio of radii of two piston is 1:3. A force of 20 Newton is applied on smaller. Find force at larger end. If smaller piston is compressed by 20 centimeter, find elongation at larger piston. Just use the above formula for the first part. I will define you the second one. Mamuna, just check your calculation. We have relation F1 divided by E1 equals to F2 divided by E2. So we have to find F2. So it will be F2 equals to F1 times E2 divided by E1. Since pistons are circular in shape, that's why ratio of radii is 1:3. So we can write pi r2 square divided by pi r1 square. Pi and pi will cancel out. So you will get F1 r2 divided by r1 whole square. On putting the value of each term, force is 20 Newton, r2 is 3, r1 is 1 whole square. So it will be 9:1. So 9 into 20, it will be 180 Newton. Mamuna, is it clear?
Yes, sir.
Wahid, any doubt? Now for the second part, smaller piston is compressed by 20 centimeter. So find elongation at the larger end. I've just assumed that this liquid is incompressible. It means volume compressed at first end must be equals to volume elongated at the second end. So amount of volume at first end must be equals to amount of volume at second end. Volume is equals to area into length. Volume is equals to area into length. Just put all the values and try to find the value of L2. Try to solve. Mamuna, again you are doing the same mistake. Since you have to calculate L2, so L2 equals to A1 divided by A2 into L1. A is area of cross section, that will be pi r square by pi r square times L1. Pi and pi will cancel out. So it will be R1 divided by R2 whole square times L1 equals to L2. As ratio of their radii is 1:3, so it will be 1 divided by 3 whole square into L1. L1 is 20 centimeter. So it will be 20 by 9. So it will be 2.2 centimeter. Good, I think. You have done correct. Sorry. Mamuna, you got this result?
Yes, sir.
Okay, good. Wahed, is it clear? Wahed, you have written? Okay. Mamuna, Archimedes principle is coming.
No, sir.
Okay, so the next part is flow of liquid, that is hydrodynamics. You have been asked only the definition about those terms for the flow of liquid, which I will define you in more detail in the next class. For the flow of liquid, just for the streamline, you will say ideal flow of liquid, for which there will be no viscosity. Suppose you have a tube like this. So velocity of liquid at each instant, let's say at this cross-sectional area, for all layer of liquid, it will remain same V1. Similarly, for this part, velocity of each layer of liquid will be V2 for this cross-section area. And it will be possible only if liquid is incompressible, there is no viscosity, there is no rotational motion in this particular liquid. So this type of flow is termed as streamline flow. But if there is viscosity, so flow of liquid will be like this. Centralmost will have maximum velocity and it continuously decreases to the end like this due to viscosity. So it is termed as laminar flow. And if there is formation of eddies like this, so it will be termed as turbulent flow. Is it clear, Mamona?
Yes, sir.
Okay, so let's stop here and good luck for your exam. We'll start surface tension in our next class.
Thank you, sir.
Thank you. Wahid, any doubt? Don't write these things. I will define little classes. Okay then, take care. Good night. Lafis. Physics paper. Okay, good luck. Okay.